Welcome to my YouTube channel. Can water actually impact the speed of a bullet? Can it completely change its direction? Today, we are diving into this exact topic. So, let's jump right over to the screen.
All right, let's dive right into this. Welcome to today's Explainer, where we're going to break down one of the most high-stakes, honestly mind-bending physics analyses you can imagine. We are pitting two massive, absolute extremes right against each other. On one side, the immense, unstoppable ballistic velocity of a fired bullet, and on the other side, water. But hey, we're not talking about a gentle stream or a heavy rainstorm here. We are talking about extreme, highly concentrated, strictly engineered water pressure. Can an element that we casually drink that flows right through our fingers literally knock a high-speed projectile right out of the air? I know, it sounds straight out of science fiction, but the physics behind this is absolutely fascinating.
So you really have to wonder, can a stream of water actually change the path of a speeding bullet? To answer this, we're going to look at a highly structured, escalating test across three incredibly dangerous levels. We'll start things off at 30,000 psi. That's pounds per square inch. Then we'll ramp it way up to 50,000 psi, and finally, we are going to completely push the boundaries of physics with a staggering 100,000 psi. We'll track exactly how many inches, or even feet, the bullet gets moved off its course, and see if its structural integrity can even survive the trip.
All right, let's kick things off with level 1, 30,000 psi, or what we call the upward drift.
To truly grasp what 30,000 psi actually means, we have to ground the math in reality for a second. Think about a standard, heavy-duty pressure washer. You know, the kind you might rent to clean the stubborn grime off your driveway or blast the peeling paint off a wooden deck. Those usually operate at around 3,000 psi. Our starting level today is a full 10 times more powerful than that. It is a terrifyingly fast, razor-thin jet of water. And this is exactly what our speeding bullet is going to fly directly through.
So what exactly happens upon impact? Well, when high-speed cameras capture this incredible collision, they reveal a phenomenon known as upward drift. The crucial thing to understand here is that the water is moving so incredibly fast that it acts as a dense, mechanical force. It isn't just splashing harmlessly against the solid bullet, it is physically pushing against it. As the bullet slices through this 30,000 psi stream, that mechanical force subtly but definitively degrades the bullet's perfect aerodynamic balance. And here is the real-world result of that upward drift. By the time the bullet reaches its target, that brief, brutal interaction with the 30,000 psi stream forces it to move anywhere from a few millimeters up to a full 2 inches off its original intended path. Now, in the world of ballistics, where precision is literally everything, a 2-inch deviation is a massive miss. The water has successfully altered the bullet's trajectory. But you know what? We are just getting started. Moving right along to level 2, 50,000 psi, which brings us to equal forces. Now, 50,000 psi isn't just some random higher number we picked out of a hat. It actually represents roughly the exact same amount of explosive pressure that's generated inside a standard gun barrel when a bullet is fired. Think about that for a second. The bullet is flying through the air only to violently slam into a wall of water that is pushing back with the exact same immense force that launched the bullet in the first place. It is quite literally a perfect kinetic stalemate. So how does the physics of this specific collision play out? It basically breaks down into three pretty chaotic steps. First, the 50,000 psi water impacts the bullet. Second, and guys, this is the absolute key to everything, it completely destroys the bullet's gyroscopic spin. You see, a bullet flies straight because it's spinning like a top, cutting perfectly through the air. The water hits it with such equal, devastating force that it completely breaks that stabilizing spin. Which leads us to step 3. Without that gyroscopic stability, the bullet instantly loses its aerodynamic angle and just begins to violently tumble end over end uncontrollably through the air. And because the bullet is now tumbling erratically rather than flying cleanly, the deflection increases dramatically. The destruction of its spin throws the bullet a full 5 to 6 inches away from the target. We have literally tripled our deflection distance just by matching the bullet's own launch pressure. At this point, the bullet has completely lost the fight to maintain its course.
And now for the grand finale, level 3, 100,000 psi, where water becomes rock.
How in the world do we even achieve this terrifying level of pressure? Well, we have to look at industrial water jet cutters. These are massive machines specifically designed to slice through thick plates of solid steel and titanium. At 100,000 psi, the water jetting out of the nozzle is traveling at an unbelievable Mach 3.
That is 3 times the speed of sound. Because of this immense velocity and pressure, the water undergoes an absolute extreme physical transformation at the very point of impact.
Literally, at this extreme pressure, water is no longer a liquid, it becomes a solid rock. Let that sink in for a moment. The fluid dynamics change entirely. When the speeding bullet hits this Mach 3 stream of water, it isn't splashing into a puddle. The sheer, unyielding density means the bullet is effectively slamming headfirst into a solid brick wall.
And the outcomes of hitting that liquid rock are shocking, and they depend entirely on what the bullet is actually made of. If you fire an ultra-solid, armor-piercing bullet through this 100,000 psi stream, it somehow survives the impact, sure, but the colossal kinetic shockwave throws it vastly off course, deflecting it a massive 1 to 2 feet away from its target. But what if you fire a standard lead bullet? The result is incredibly violent. The standard bullet simply cannot handle the impact of Mach 3 water. It doesn't deflect, it just blasts into fine powder the millisecond it touches the stream. We're talking complete and utter disintegration.
Bringing it all together now with our final deflection verdict.
Let's quickly review the data we've got here. At 30,000 psi, the upward drift nudged our bullet up to 2 inches. At 50,000 psi, where we matched the gun zone pressure, we broke the gyroscopic spin and pushed that deflection to 6 inches. And finally, at that monstrous 100,000 psi mark, we turned water into rock, resulting in a massive 24-inch or 2-foot deflection for the armor-piercing round and total vaporization for the lead round. As the pressure increases, the bullet's path, angle, and structural integrity are exponentially destroyed.
The exponential nature of these fluid dynamics is just staggering. We go from a minor 2-inch drift straight up to a monumental 2-foot deflection. It really lets the immense power of physics sink in. Water, given enough pressure and velocity, completely and totally dominates steel and lead.
Which leaves us with this final kind of mind-blowing thought to chew on. If water, literally the exact same stuff that comes right out of your kitchen sink, can be engineered to turn a speeding bullet into powder, what other everyday, seemingly soft elements around us are hiding this kind of world-breaking power? Physics is happening all around you, often in ways that totally defy common sense. Thank you so much for joining me for this explainer, and hey, I hope this changes the way you look at the physical world today.